Hello students, Miss Slyman here to finish your 6.2 and 6.3 notes. I'm not going to go through finishing the proofs with you because really that's just an exercise for us to get stronger in our mathematical proofs, so feel free to continue to do that on your own. I will give you a hint for tan A plus B. Work backwards from what's in the formula booklet. So if you look at what's in the formula booklet, here's the things that you should end up proving. And these are the formulas that you don't need to memorize because they're in the formula booklet. But if you start with tan A plus B and write out the sine A plus B over cos A plus B, work backwards from this to get to that point if you're trying to prove the tan A plus B formula. But otherwise, we're just going to use these formulas. Okay, so show that sine of pi over 3 plus pi over 4 is root 3 minus 1 over 2 root 2. So I notice first here's my denominator of 2 root 2, and it looks like root 3 over 2, and it looks like 1 over root 2, which tells me that for pi over 4, they're using 1 over root 2 rather than root 2 over 2. So let's go look at our sine formula. Sine A plus B is sine A cos B plus cos A sine B. So this is going to be sine pi over 3 cos pi over 4 plus, oh, and this is where I told you was the typo, that should be a plus sign, plus cos pi over 3 sine pi over 4. Hopefully this is going to end up working, actually. Let's see. So sine of pi over 3, that's the short angle, that's a half. Cos of pi over 4, oh, sorry, that's not the short angle, that's a tall angle. Pi over 6 is a short angle. That is root 3 over 2. Cos of pi over 4, that's 1 over root 2. Plus cos of pi over 3, that's a half. Sine of pi over 4, I don't need to write sine again, is 1 over root 2. So I have root 3 over 2 root 2 plus 1 over 2 root 2, which is root 3 plus 1 over 2 root 2. Okay. Expand cos A plus pi. Well, we saw this morning that that's going to be, I don't remember, and it's not something you need to remember, cos A cos B minus sine A sine B. Okay, so cos A cos pi minus sine A sine pi. Well, sine of pi is 0, so that whole quantity becomes 0. Cos of pi is negative 1, so this turns into, let's put the negative in front, negative cosine of A. So cos A plus pi. And if I think about this, the left-hand side is my cosine graph shifted by pi to the left. So let's make a sketch of that. Cosine graph normally starts up and comes down, and it hits the down point at pi. So now I'm moving it pi to the left. My down point is going to be here. So I'm going to have, this is my down point coming up. Here's my pi now. So I moved it over pi to the left, but I can see that this is just a reflection of the cosine graph. It's negative cosine. So my expansion makes sense graphically as well. Okay, I'm going to use the sine rule. So sine minus is going to be this rule, except with a minus sign. So sine, cosine, cosine, sine. So sine pi over 2 cosine of x plus cosine pi over 2 cosine, sine of x. Again, I have a 0. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So this turns into equals, let's change the color on that, equals cosine of x. And if I think about what this is saying, I can think about it geometrically as well. And I encourage you to make those sketches. Exact value of cosine 75. Well, that's going to be cosine of 45 degrees plus 30 degrees. And now I can use my cosine law. That's going to be cos 45, cos 30, minus sine 45, sine 30. And I want to make sure that I've got my signs correct. I think so. Let's see. So here I have a plus, here I have a minus, my cosines come first. Okay. Again, you don't have to memorize these. Use your formula booklet. I just don't have a formula booklet sitting in front of me. So cos 45, I'm going to use root 2 over 2. Cosine of 30, root 3 over 2. Minus sine of 45, root 2 over 2. Sine of 30, 1/2. So this is going to give me root 6 minus root 2 over 4. If I wanted to, I could have taken out that root 2. It doesn't really make it prettier, though, to say root 2 times root 3 minus 1 over 4. Either one of those is an exact answer. So there we go. Okay, prove sine A plus B times sine A minus B, sine squared A minus sine squared B. So sine A plus B, that's sine A cos B minus sine B cos A, all multiplied by sine A cos B plus sine B cos A. Okay, if I do my FOIL, I'm going to end up with sine squared A cos squared B. This is a difference of squares, so my middle terms, I believe, are going to cancel. Yes, they are. My last term is going to be minus sine squared B cos squared A. And how does that turn into sine squared A minus sine squared B? Somehow it would be great if our cos squared B and cos squared A turned into 1. Okay, so one thing that I've realized is that I had my formulas wrong. This should actually be a plus. This one should be a minus. So let me fix that. This one should be a minus. This one should be a plus. It doesn't change anything down here, though, so that's okay. It's still the same. And I want to end up with this, so I want to change these, and I want to get rid of the cosines. I can't just magically change them into 1. What I can change them into, so I'm going to leave that sine squared A. I'm going to change my cos squared B into 1 minus sine squared B, minus, I'm going to leave the sine squared B, and change the cos squared A into 1 minus sine squared A. And then when I distribute, I'll have sine squared A minus sine squared A sine squared B, and now minus sine squared B, but then plus sine squared A sine squared B. So those middle terms are going to cancel. It's like another difference of squares. So I'm going to end up with what I wanted, minus sine squared B, because these multiplied terms are going to cancel out. So we can even write our QED. Okay, so I'm solving this equation. If I look at this, I've got cos, cos, sine, sine. This is the cosine rule, and because it's plus here, that means it's going to be cos of x minus pi over 3. So cos x minus pi over 3 equals root 3 over 2. Well, I know that cosine is equal to root 3 over 2. Sorry, that's pi over 3 there. The cosine is root 3 over 2 at 30 degrees, which is the same as pi over 6. It's also true at negative pi over 6 because it's cosine, so that's in our quadrants 1 and 4. And I can just add 2 pi to all of those. So when I add 2 pi, I'm going to have 13 pi over 6. I'm going to have 11 pi over 6. And if I think about from 0 to 2 pi, generally I should be ending up with about 2 answers. So now I've got to add this pi over 3 to the other side. So I'm going to move that to the other side. Pi over 6 plus pi over 3, that's 3 pi over 6, which of course I can call pi over 2. Negative pi over 6 plus pi over 3, that's going to be pi over 6. 13 pi over 6 plus pi over 3, that's going to be too big. 11 pi over 6 plus pi over 3 is too big. So both of those answers I don't need. And here are my 2 answers. Okay, example 9. Here we've got tan x plus tan of 2.1 minus equals 1 minus tan x tan 2.1. I notice that if I divide, I'll have tan x plus tan 2.1 divide by tan x tan 2.1. And I don't know if I wanted to divide that way or the other way, because I can't remember what the rule says. And the rule says plus on the bottom, 1 minus on the bottom. So I actually wanted to divide with the 1 as well. Sorry. Okay. So I wanted to divide with that 1 as well, 1 minus, and that's going to equal to 1 on the other side. And, of course, if I'm going to divide, I have to divide by the whole thing. That's the same as tan x plus 2.1, and now I want to know when that is equal to 1. So I can think about when tan is 1, that's at 45 degrees, which is pi over 4. So x plus 2.1, that's pi over 4, not pi over 3, pi over 4. It also happens in quadrant 3, so that's going to be pi plus pi over 4, which is also 5 pi over 4. And I'm going to be subtracting 2.1, so this answer is going to be too small, so I'm going to add 2 pi to it because that's going to give me my next one. Remember, tan is periodic with pi, so I just keep adding pi each time. So 2 pi plus pi over 4, and then you need to subtract the 2.1 to get your answers. This answer will be out of range, and that's going to get our x by itself when we subtract it. Okay, sine of x plus pi over 4. Well, that is sine x cos pi over 4 plus cos x sine pi over 4 equals root 2 cos x. So this is root 2 over 2 sine x plus root 2 over 2 cos x minus root 2 cos x equals 0. Root 2 over 2 sine x, And then this is going to be minus root 2 over 2 cos x equals 0. Well, I'm going to move that to the other side. I'm going to divide both sides by root 2 over 2. I'm going to divide both sides by cosine. Divide by cosine. That's going to give me 1 on this side. So I've got the equation tan x equals 1. And I will leave that for you to solve between 0 and 2 pi. Okay. So now I have root 3 sine x plus cos x. I want to express the function in the form a sine of x plus theta. So let's think about how we would do that. So sine of, sorry, not x plus theta, x plus phi is going to be sine x sine phi plus cos x cos phi. Well, in this case, I'm going to want somehow to end up with root 3 here and somehow to end up with a 1 here. But we had an a in front of everything, so this would be a, which would make an a here and an a here to factor out. So when I am thinking about this, clearly I'm thinking about that root 3 tells me that my phi, if I let phi be pi over 3, then I would end up with a sine root 3 over 2 plus a cos x of 1/2. Well, if a is 2, then those are going to cancel. So I shouldn't have put an equal sign here. So now if a is equal to 2, then I end up with sine x, I forgot the x there, root 3, I can move that root 3 in front, plus cos x. So I can rewrite that function as 2 sine of, I didn't really need this parenthesis here, but I do need parentheses here, sine of x plus pi over 3. And there's my equation. I can now take this equation, replace it here, and set it equal. So here's my y equation. I can set this equal to root 2, divide both sides by 2, and then I'm going to end up with being able to solve because I know that x plus pi over 3 is going to be equal to pi over 4. Okay, those were the notes on 6.2, and tomorrow I'm going to make another video on 6.3, but I'm going to stop now because it's late enough.